Okay, solving rational equations. So two methods. First one, find a common denominator and equivalent rational expressions, then set the numerators equal to each other. So that's the first method. Second one is multiplying both sides by the lowest common denominator. So in method one, you take a look for your lowest common denominator. You need 5 and you need x. The other 5 is already included. So it's not 25x, it's 5x. So then in this method, you find equivalent fractions for each one. Okay, so 5x means here we have to multiply top and bottom by x, the first one. And then the next one by 5. And the last one by x. Okay, and then you can show basically with the same single denominator on the left, you can show it as one fraction. Okay. You're not going to reduce anything. In this method, you want the denominators to all be the same. So now, if these denominators are the same, there's one fraction here, one here, that means the numerators have to be the same. So I use the 3 dots in a triangle. That means therefore, x squared minus 3x plus 10 is equal to x squared. Okay, so if you get it down to a fraction on each side with the same denominator, then the numerators have to be equal to each other. Okay. Now with that equation, you want to collect like terms. It is quadratic, which means you would get one side equal to 0, except in this case, it's actually not quadratic, right? The x squareds add to 0. So really, it's a linear equation. Negative 3x plus 10 equals 0. Okay, and then you want to isolate x. So subtract 10 from both sides and divide by negative 3. With all rational equations, you need to look for your non-permissible values, right, your restrictions. So you go back up to the original, okay, before you just looked at the numerator, and your factors are 5 and x. Well, 5 doesn't do anything. The only value that makes this 0 is if x is 0. So make sure you state that somewhere. You always want to check. Is the solution you got a non-permissible value? If it is, then you have to eliminate your solution from the solution set. Okay? But in this case, it's not the same, so this is your solution. So we often put them in squiggly brackets, in the solution set. Okay. So the other method is where you figure out the lowest common denominator. So we already know that. Okay. Exact same equation here. We're just using a different method. So lowest common denominator, and then you multiply both sides by it. Remember what I said. Whatever you do to one side, you have to do to the other. So if I multiply through by the lowest common denominator on both sides, then I've treated both sides equally. I'm not changing the equation, okay? not making it unbalanced. It's still balanced. And if you've chosen the lowest common denominator correctly, when you multiply through here, each term, okay, then these denominators will divide into your factor, and you won't have any denominators left. So rather than expanding this numerator first and then dividing by 5, I do that part first. So 5 goes into 5x, x times, and then it still has to be multiplied by x minus 3. Then here, x goes into x 5 times, and it still has to be multiplied by 2. Equals 5 divides out with 5 here, you get x squared. Okay, so if I expand that out, I get exactly what I had here. Okay. Fewer steps, right? A little bit faster. Always nicer, I find, to deal with things that aren't fractions, whether they're rational expressions or numbers or whatever. So I like this second method better because then it gets rid of the denominators and you're done with denominators. Okay, the whole thing. So then here, when we solve this, we get exactly the same equation, right? Okay, so that's your solution, because you know that x, you go back up, you know your lowest common denominator is what you look at for your restrictions, so x can't be 0. Okay. Most times you'll end up, after some, maybe not right now in this course, but probably by next semester, doing it this method too. You might keep doing method 1, which is totally fine for now, because it makes sense to you with keeping those denominators the same, etc. But then after doing a number of these, you may probably, hopefully, go to method 2. Okay? We don't care on a test. It's totally up to you. We're not going to say use method 1 or method 2. It's up to you. Okay? So, next one. Take a look. Numerators are actually equal to each other, but the denominators aren't. Okay? So, lowest common denominator. Notice how there's a 2x here, and there's also a 2x here. Okay? But this 2x is not a factor. Remember, it has a subtracting next to it. So your lowest common denominator is not just 2x minus 1. Okay? You have to have that, but then you also have to have the other denominator 2x. Because this 2x is not a factor. There's a subtracting next to it. Really, it has brackets around it. Okay? So, in our first method, we show with your lowest common denominator. Okay. So if this is the method you like, that's my first step. Don't even look at the numerators. Show every fraction with that common denominator. Okay, so how to get that denominator, I have to multiply top and bottom by 2x minus 1. So really this is 2x minus 1 in red. And this will be 2x minus 1. Okay, and so the original numerator was x plus 1. Put brackets. Right? Can't just show it as x plus 1. It needs to be in brackets. And then on the right side, we have to multiply this by 2x, so we have to do the same in the numerator. And what was there before was x plus 1. Right, so these are the same now. So you can use your therefore statement x plus 1 times 2x minus 1 equals 2x times x plus 1. Okay? Or you can think about it as multiplying, it's kind of a combination. Really, when you're going from here to here, you're multiplying through by the lowest common denominator. But because they're the same, you're just looking at the numerators. And now expand out. And plus like terms. Does look quadratic, yeah. You could expand it, yeah, if you wanted to do here or there. Yeah. For sure, you can expand it out. It's quadratic, so normally you get one side equal to 0, except for, actually, it's not quadratic. Those go to 0. So then I'd actually subtract x on both sides. Okay, and I like to show this with the x first. So this had -1 and then x on the right, but I just like to rearrange it. Okay, when you're solving the equation, it's better to have the x or variable first. Okay, then let's check our restrictions. Can't have 0, can't have 1/2. And so my solution is good. From the denominator here. What makes this 0 is +1 divided by 2. Okay, so the other method is 2x times 2x minus 1, both sides. Because there's only one fraction, it actually works out, you can just divide that and get 2x minus 1 times x plus 1. Those divide out. And here, 2x minus 1's divide out. And so you'll notice you get the same thing as this. These are the same. So I'm not going to show all those steps, right? It's going to be exactly the same as what you did here. So my solution is x equals -1. This saves you a step, really. Nothing to it. Next one, you need to do some factoring. So whenever you're solving rational equations, factor everything first. That might help you get the lowest common denominator. Right now, if you didn't factor, then it would be this times this, which really would be a degree 3. Okay? That would end up meaning that you're gonna probably have to factor at the end to reduce. In this case, though, this can be factored, and maybe one of the factors is x minus 8. So check that out. So that's good. This doesn't have brackets, but you can put brackets around it if you want. So your lowest common denominator is this, the left-hand denominator. So that means that really all you have to do here, so I'm going to copy this out with that common denominator. And so I'll just have to multiply this by x minus 5, top and bottom. Okay. And so that means now, those denominators are the same. It means 9 equals 3 times x minus 5. And if you want to expand out in that step, then you're welcome to do so. So really 9 equals 3x minus 15. And add 15 to both sides. Okay, divide by 3. And show x on the left. So x equals 8. But take a look at your restrictions. Go back to your lowest common denominator, x minus 8 times x minus 5. And we know we can't have 5 or 8. Well, 8 is one of them here. So you have to eliminate it from your set. And it's the only one there. So really, there are no solutions. So you either write the word no solutions, words like this, or you do those set brackets with nothing inside. Okay, so that, or this, or null set. So 0 with a slash in it means no solutions as well. Okay, what we call this is an extraneous solution. Okay. It's extra, that word extraneous, extra. It is found because we're really working with rationals. We're multiplying top and bottom that second rational by something with x in it. So we actually introduce a possible solution. Got to do your verification with the restrictions. It doesn't verify, so then really there's no solutions. Okay? You still need to show x equals 8, so don't just erase it. Do like I've done. Show x equals 8, show your restrictions, cross out the 8, and then make a statement. One of those 3 ways. Okay. So the other method, what would be different? Not too much, really. You show your factored form. And then you multiply through by your lowest common denominator. And so you can see the whole denominator divides out and you're left with 9. Here the x minus 8's divide out, you're left with 3 times x minus 5, which is exactly the same here. And then you follow the same, and then you've got no solutions. Oh, that is not clear. Okay. Just a teeny bit faster. Next one, we've got 3 rational expressions within that equation. So factor everything first. If you just went for the lowest common denominator now and just multiplied them all together, it wouldn't be the lowest. Because x squared minus 9 can be factored. So factor everything. Okay, so we're going to factor the right-hand side, which is x plus 3 times x minus 3. Okay, so that's your lowest common denominator. Right, there's an x plus 3. We've already got it in there. X minus 3, we've already got it. So the right-hand side, we don't have to do anything. So here, so this, x plus 3, x minus 3. Alright, so this method, a lot of writing when you have to find that, so that common denominator. Okay, now we have, so really here we have to multiply by x minus 1. So to get that common denominator. Okay, really here we have to multiply by, oh, what did I just do? Not 1, x minus 3. Sorry. There we go. There we go. Fix that up. Okay? Then the next one we have to multiply by x plus 3. Okay, top and bottom. We'll just put the monomial out front there. And the last one, nothing changed. Okay? So now, one fraction on each side. And you can expand at the same time if you want. So that would be 2x squared minus 6x plus x squared plus 3x. Okay. You can get rid of the brackets at the same time, just to save a little bit of time. Okay. And now your denominators are exactly the same. So this numerator is equal to 18. And again, you can collect like terms if you want. That would be 3x squared minus 3x equals 18. And this is quadratic, so get one side equal to 0. And here, with a quadratic, you have to factor. What you'll notice is there's a common factor of 3. When you have an equation, you can actually divide out by that 3. You don't have to just factor it, because one side is 0, right? So as long as you treat each side the same, then you can divide. You multiply or do whatever you want, but this will end up being easier to factor, right? You divided out that 3. So now factor. Yeah, that's not wrong. Okay, so then this factors. If it doesn't factor, then remember we did somewhere you had to graph it. next semester, you'll learn the quadratic formula. Okay, so there are other methods. So this is going to be -2 and +3 when you solve that. Look for your restrictions. And you'll notice that they are -3 and +3. Well, one of your solutions is one of the restrictions. So we have to cross it off, eliminate it from our solution set, and then I always make one final statement then. Okay, I don't want to leave it like that. Just so it's, oops, that's a -2, just so it's clear, x equals -2. Now, for the other method, really, we want to factor, so this is going to be the same. Okay. Then you multiply 3 by your lowest common denominator. And then put brackets around the whole, each whole side. Okay. Then you multiply each fraction. So I don't cross anything out because then it'll get confusing what's crossed out. It's always these two factors times the first. So the x plus 3 is divide out. You're left with 2x times x minus 3. Then plus x minus 3 is divide out, so plus x times x plus 3. And then here it all divides out equals 18. Okay. So that's kind of equivalent to this step here. And if we expand, okay, we get equivalent to this step, except that has the denominator. And then if we collect like terms, and these are the same, right? And so you solve it the same way. I'm just not going to do it twice, right? Okay. Next one. Okay, again, factor first. That right-hand denominator can be factored. If you don't do that, then that's okay. You can still solve it, but you have to reduce at the end. So best to factor first. 2 is common. And that was kind of weird. Okay, so 2 times x minus 1 is the lowest common denominator. Okay, because this is x minus 1 here, so it's like a factor. So 2 times x minus 1 So there's nothing to change on the right-hand side. On the left, we had to multiply this by 2. Okay, there was a 2 there to start. Okay, now your denominators are the same, and so really what that's saying is 4 equals 1. Is 4 equal to 1? No. There's no x's there. So there's no value, no matter what you put in for x, there's no way you can make 4 equal to 1. So you simplify this down to as much as you can, to the number. They turn out to be numbers, no variables. So there's nothing to solve for, first of all, and there's no way that these are the same. There's nothing you can do to make 4 equal 1, right? We know what 4 is, we know what 1 is, and they are not the same. So this has no solutions, as there are no values. Make no solutions, as there are no values of x that make the equation true. 4 is never equal to x. Sorry, equal to 1. Okay. And same thing, if you were to do it the other method, you'd still factor and multiply through by your lowest common denominator. You ever heard of the method called cross multiplying? That really comes from this. This is the proper way to do it. Cross multiplying is sort of a fast way to think about it. And I just put a question mark because when is 4 equal to 1? Never, right? So. And then the last one, I think it's the last one. Same thing, factor those denominators first. Hopefully there's some common factors. And reduce. Anything that's common within a fraction, reduce it if you can. And what you end up with is 2 over x minus 5 equals 2 over x minus 5. Okay, they're exactly the same. So 2 is equal to 2. Right? Doesn't matter what x is. So x can be anything. Except for the non-permissible values. It can be any real number. Except for, go back to your factored form here, before you divided anything out. Can't be 0, and it can't be 5. So it can be any value except 0 and 5. So how could you say that rather than using words? Kind of like your domain, except we don't need the x with the bar because it's not representing the function. We can just say x not equal to 0, 5, but x is an element of the set of real numbers. So that would be a way using set notation to show all the solutions. So basically, any value of x, you can put in 3, you can put in 10, you can put 102 in, you put 1.3 in, but you can't put in 0 or 5. Okay? Into the original. And so the only thing different here, you factor it. So the first steps are the same. Divide that out, that, and then your lowest common denominator, so this would be 2 over x minus 5 equals 2 over x minus 5. Really, would you bother showing multiplying through? Not really. Hopefully you can see that they're exactly the same. But your common denominator now is x minus 5. So those divide out, and you get 2 equals 2. Alright? So really, it's the same steps.